Okay, it's okay. Can you hear me?
Yes, we can hear you. Good to go. The stage is yours. You can go ahead.
Okay. Well, greetings everybody. I hope this presentation is interesting to everyone. Starting with the name of this event, recycling and waste management, I would like to say something related to the item. Countries develop economically without adequate waste management systems. It's estimated that in 2016, 1,600 million tons of CO2 were generated from municipal solid waste management. It's a very big problem, representing 5% of global emissions. Without improvements in this sector, these emissions are expected to increase in 2,000 tons in 2050. This is a big problem. On many occasions, adequate management of municipal solid waste is not considered in city planning, perhaps because this issue has not yet generated much social awareness. In Mexico, that's happened unfortunately a lot. In fact, I have noticed, at least here in Mexico, where I live, at the university where I am, UNAM, in the area of environmental engineering, that masters and doctoral students almost always prefer drinking water treatment issues, wastewater treatment matters, but waste management topics are not among the preferred options. That's really a pity. Well, let's get started then. If you don't mind, I will use some notes to make my presentation more orderly. First, I would like to to say thank you to the organizer of this event for accepting the presentation of this project and for giving me the opportunity to participate in this project and this event, Recycling and Waste Management Summit. I would like to especially thank President STEM Prevent Patola. I hope I pronounced your name well.
Yeah.
My name is Alfredo Martinez. I'm from Mexico City. The project has been developed in the Engineering Institute of the National Autonomous University of Mexico, as we say, UNAM. I would like to talk a little about my university and my institute. The UNAM is made of more than 360,000 students. Yes, you heard well, 360,000 students. The UNAM is ranked 100 in the QS World University Ranking 2021. The UNAM is one of the two best universities in Latin America. The Engineering Institute is made of more than 200 researchers in different areas. This project is carried out in the Engineering Institute of the UNAM. I don't know if you can see the pictures. This is the pictures of the campus of the university, the central library, uh, pictures of the installations on the Institute of Engineering. This is the lab where I work in the Institute of Engineering. I'm part of the research group directed by Dr. Maria Neptali Rojas Valencia. The title of the project is Application of a Biological Electrochemical Treatment Train to Leachate and its Analysis of Organic Matter Degradation. That's the title. You can see the order on my presentation, the classic order, background, objectives and goals, methods, expected results, conclusion, and contributions. Let's begin. According to official data, Mexico City produces more than 12,000 tons of waste per day. 12,000 tons of waste, municipal solid waste, 12,000 tons. This quantity of 1,000 tons is generated by the 21 million people who live here in Mexico and its metropolitan area. As is well known, Mexico is one of the most populated cities in the Americas, only after Sao Paulo and New York. The growth of commercial and industrial activity, as well as society's general tendency towards consumerism, have led to an undeniable increase of the rate of municipal solid waste generation. Worldwide, municipal solid waste management is expected to exceed 2 billion tons in 2026. It's a very big problem. Comparative studies on various methods of municipal solid waste management have shown that the most economical form in terms of operating and capital costs is the use of landfills. Harmful liquids are generated in these sites due to the filtration of rainwater through solid waste, leaching a large amount of polluting materials, and producing complex wastewater known as landfill leachate. That is the name, landfill leachate. Mexico generates more than 53 million tons of municipal solid waste. Mexico has 870 landfills. You can see the picture here. 74.56% of municipal solid waste is managed in landfills. It's a big portion. And only 34.6% of landfills have leachate collection and treatment system, a little small portion. This situation of poor control of manage or generate landfill is a big problem for landfill operators, and of course, it's a big problem for environmental authorities. Although leachate are very heterogeneous, they have a high concentration of organic and inorganic contaminants, including humic acids, ammonium nitrogen, heavy metals, as well as inorganic salts. Poor leachate management is a potential cause of environmental pollution, especially in soil, surface water, aquifers, and water courses. This project has the following objectives and goals. The main objective is to establish the technical and economical feasibility of a treatment train made up of three parts: age refuse bioreactor, electrocoagulation, and electrooxidation at laboratory and at pilot plant level, including determining the phytotoxicity of the effluents generated by classifying their effects on selected sets. Special attention will be paid to monitoring the chemical oxygen demand and dissolved organic matter fractions during the processes to understand the evolution of the treatment train and to make improvements in its operation. Landfill leachate is complex wastewater generated by landfills. A combination of physical, chemical, and microbiological processes is involved in the conversion of municipal solid waste into liquid form. Leachate contains a considerable number of organic compounds, in addition to nitrogen, phosphorus, minerals, and metals. As a result of the variable composition of the leachate, treatment methods have not been unified so far. The treatment of landfill leachate usually involves a multi-stage system of chemical, physical, and biological processes, and its treatment cost is higher than the municipal and industrial wastewater. In this research, the following treatment train is proposed. You can see the picture. In a first stage, a biofilter, an effective way to remove organic contaminants from leachate. Packaging is the main component of a biofilter, should not only be beneficial in removing contaminants, but should only be resistant to clogging and available at low cost. Currently, waste well decomposed over the years in the landfill is commonly used as a biofilter landfill medium for leachate treatment. These wastes are called age refuse. You can see the name, age refuse. The efficiency in removing contaminants is mainly due to their physicochemical properties. In a second stage, we have electrocoagulation before the chemical oxidation processes. The electrocoagulation will improve the overall efficiency of the treatments by reducing the interference of suspended and colloidal species, reducing the organic load by precipitating humic substances, such as humic and fulvic acids. The use of cathode-anode system is proposed. Iron, stainless steel, that's the proposed. In a tertiary stage, we have electrooxidation using an anode cathode system, both doped diamond and stainless steel. The electrooxidation will degrade the recalcitrant organic matter and oxidize the ammoniacal nitrogen. The research methodology will be carried out on 6 different stages: sampling and characterization of the shade, extraction and conditioning of edge refuse, characterization of edge refuse, bioreactor operation, operation of electrochemical processes, including electrocoagulation and electrooxidation, and finally, the escalation of the processes. The study area is in Mexico City. Mexico City has one of the largest landfills in the world. The landfill called Verde Poniente Landfill, BP Landfill. BP Landfill is one in the northwest area in Mexico City. BP Landfill has an area of more than 1,000 hectares. You can see the map here. This is the Mexico City. 1,000 hectares. To measure what this area represents, 1,000 hectares is the equivalent of a square area of 100 kilometers per side. A square area of 100 kilometers per side. I think you can give an idea of what size of this landfill. It's a very, very big. BP landfill is currently closed and operated from 1985 to 2011 and received more than 82 million tons on municipal solid waste. Okay, the fractionation of the dissolved organic matter will be done according to the solubility of its different components. In this way, the fractions corresponding to the humic acid type substances, fulvic acid type substances, and hydrophilic fractions will be obtained. In this slide, you can see the details of the methodology that will be used for this analysis. Okay, in addition to the conventional characterization of using chemical oxygen demand, organic carbon, and biochemical oxygen demand, is proposed to perform the use of the dissolved organic matter by fractioning the chemical oxygen demand, getting its inert, soluble, and particulate fractions. You can see the picture here and the parts of the COD. This allows determining the content of the dissolved organic matter in the shades and terms of their composition and origin, thus supporting the choice of an appropriate treatment. In the treatment of the shades, this is important. The application of electrochemical processes don't consider that as far as the elimination of organic matter is concerned, it could be possible to generate byproducts of a more hydrophilic nature than the original organic matter, therefore more difficult to eliminate, and even more toxic than the original matter. Using selector sets, lettuce, beans, and cucumber, phytotoxicity tests of the effluent from the proposed treatment train will be developed to determine whether any reduction of organic matter has increased the toxicity of the effluent. The parameters to be evaluated will be average germination rate, germination inhibition, germination index, and growth inhibition. Once the stage of the experimental level has been complete, it's expected that the proposed treatment system will be expanded to the pilot plant level through the analysis of the kinetical conditions of the processes, considering that the value of the chemical oxygen demand will be the target variable. Something that is important to note is that this project is in the process of development. So far, the sampling of the electrodes, the extraction of the edge refuse, and the preliminary test phytotoxicity have been carried out. You can see some photos of the processes: extraction of edge refuse, electrode sampling, and preliminary phytotoxicity test. This research is expected to be complete during 2021, well, as long as conditions allow. As contribution and expected results, the following are highlighted. The fractionation of dissolved organic matter and COD will be analyzed in the proposed system. A detailed characterization of the degree of mineralization and conversion on organic matter of different sites and molecular weights in the treatment system will be established. Operational guidelines for the treatment system will be established to improve its performance and efficiency, first on the laboratory level and then on the pilot plant level. The phytotoxicity of the wetlands generated in the proposed treatment train will be evaluated. The characterization of the age refuse will be carried out. It's expected to develop at the stage of the proposed treatment monitoring graphs of TOD and dissolved organic matter fraction values to understand the processes and make proposed to improvements. As my conclusion, it's expected that the proposed treatment system will be defined as a sustainable option for leachate treatment. I want to say that the project is still in development. It's all for the moment. You can see the email if you need some information, something to say. If any of you have any question, it will be my pleasure to answer them. And you have here is the mail, my mail, and the Doctora María Nectari Rojas Valencia. And that's all.